In the sweat-drenched roar of the Mare Island Naval Shipyard, the morning fog lay thick over the docks, turning girders and gantries into ghostly silhouettes. Welders' arcs flashed in the dim light, each ignition a small star against the steel. Skeletons of warships rising over the water. Ted Nelson wiped his brow, muscles tight from another night shift, and squinted at a length of deck planking. All around him, men scurried beneath scaffolding like ants on a steel hill. Somewhere far below, a group of workers tapped in through bolts to secure the wood decking to the steel frame. Then more would come to tack weld the nuts, to keep them from vibrating loose. A painstaking, time-consuming job that constantly held up progress. Ted hated waiting. He had joined Mare Island as a simple welder, but his mind worked on a different plane. To him, every deck board and every bolt wasn't just a piece of material. It was a problem to solve, an inefficiency to eliminate. He gripped his welding helmet tighter, the leather strap pressing into his forehead, and wondered how many hours they were losing every day just because they tied themselves to tradition. Below deck, someone called out, "One more scaffold plank." To go here, Ted's jaw clenched. He took a step forward and then stopped. No, not one more scaffold. He had an idea, half crazy, maybe, but it had been haunting him for weeks. A way to weld studs directly from the top side, to eliminate the need for nuts and through bolting, to cut out all that lower-level scaffolding. That night, he stayed late in the shop. The welding and cutting shop at Mare Island had grown into a cavernous beast. During World War II, it expanded into multiple wings. The forge shop, the ship-fitting shop, hundreds of machines humming day and night. Library of Congress style. Ted dragged a workbench into a dim corner under a swarm of overhead lights. He pulled out a steel stud, short, threaded, and looked at it carefully, turning it in his calloused hands. Then he picked up a small cap, fashioned in his mind like a little rocket, loaded with flux. His gun, as he called it, a crude handheld welding device that looked a little like a drill. He'd salvaged some parts, coils, a timing mechanism, a heavy metal body. Tonight, he would build a first prototype. He inserted the stud into the chuck, attached the cap, and connected the whole device to the power supply. Then he held his breath, pressed the trigger. A spark, a small arc. The stud bounced off the plate. In less than a heartbeat, the flux cap imploded, the metal melted, and with a soft thunk, the stud slammed home, fusing to the steel below. Ted yanked off his helmet and stared at it. It held, the joint was solid, seamless. He suppressed a grin. He whispered to himself, "By God, it works." Morning came, and Mare Island was alive again. Shipwrights hammered, welders shouted, and sparks flew like fireworks. Ted carried his prototype gun in a battered toolbox. He wasn't fool enough to expect immediate acceptance. He had learned that much. But he was going to show someone, anyone, what he'd made. He found his foreman, a grizzled veteran named Harris, near a deck under construction. Harris looked up as Ted approached, sweat streaking his dirty face. "What you got there, Nelson?" Harris growled. Ted opened the case, carefully lifting out the welding gun. "Something new," he said, voice steady. "Let me show you." They moved aside some plywood. Ted drilled a shallow, pre-drilled hole in a piece of deck plank. He set the stud in, held the gun steady, and squeezed the trigger. The arc flared. Brief, but bright. The stud fused, the cap collapsed, and when he removed the tool, the joint was tight. No nuts, no bolts. Harris frowned, leaning closer, running a gloved finger along the joint. Then he nodded slowly. "All right, Nelson. That's not bad." Ted felt a surge of pride, not just for himself, but for what this could mean. Less scaffold, fewer men crawling under the decks, faster work. But not everyone saw it that way. When Ted tried to explain to the shipyard engineers, they bristled. Traditional methods were safe, proven. Through bolting, nuts, tacking, they had always worked. One engineer, a sharp-suited man named Sullivan, looked at the gun with cold skepticism. What you're proposing is reckless, a gadget, not a tool. We need reliability, not experiments. Ted stood his ground. Sir, this produces a full penetration weld from the top side. We save time, manpower, materials. Sullivan shook his head. Talk is cheap, Nelson. Bring me data. Bring me tests. Otherwise, no. Ted nodded. He knew the road ahead would be hard, but he believed in the gun. He believed in his method. Over the next weeks, Ted and a handful of trusted welders ran tests in secret. After midnight, when most of the yard slept, they set up small rigs, wood boards over steel plates, pre-drilled, stud after stud, welded one by the little gun. They measured shear strength, pull-out strength, and fatigue. Every test they ran, the joints held firm. Word began to leak through the ranks. Some welders whispered about Nelson's rocket gun. Others laughed, calling it his mad little idea. But when a few trusted foremen saw the results, their laughter died. One evening, Ted walked into the foreman's office with a small stack of test samples clutched in his hand. "These are from last night," he said quietly. "Pull test them, if you like." The foreman picked one up, examined it, and dragged it over to a bench. With a lever arm and a weight, he performed the test. The joint held. Not just held. It resisted until the very end. He looked at Ted, a grudging respect in his eyes. "This could save us a lot of work," he admitted. The war came. December 1941 changed everything. With America now fully at war after Pearl Harbor, the demand for warships skyrocketed. Mare Island grew faster than ever. By 1945, the workforce swelled to tens of thousands. Wikipedia. Every minute on the dock counted. The Navy couldn't afford delays. Ted saw his moment. He pitched his stud welding system to the yards. Executives laying out his test results, his strength data, safety protocols. At first, they balked. But with the pressure mounting and production goals slipping, they relented, cautiously. They tried his gun on a small section of a submarine deck. The welds were clean, fast, and strong. Scaffold time dropped dramatically. Labor costs fell. Deck installation accelerated. Word spread to other shipyards too. Nelson's invention drew attention. The Navy recognized its value. Over time, the stud welding method was rolled out widely. By the war's end, the savings were staggering. The process had eliminated large amounts of scaffolding, slashed man-hours, and accelerated deck construction in a way that once seemed impossible. In fact, Ted Nelson's innovation is credited with saving on the order of 50 million man-hours during World War II, Pacific paratrooper. And yet, through all the success, Ted remained humble. He didn't raise himself up as a war hero. He was just a welder, a problem solver. After the war, he founded his own company, Nelson Specialty Welding Equipment. His stud welding guns and studs became standard not just for warships, but for construction, bridges, and industrial projects. Pacific paratrooper. He even earned 2 Navy E-citations for outstanding production during the war. Pacific paratrooper, the iron skeletons of warships that once echoed with hammer blows and welding arcs, are mostly gone now. But Mare Island's legacy lives on. The island itself, once packed with 50,000 workers at the war's height, is now partially redeveloped. But the story of innovation remains. Ted Nelson died years later, but his mad welding gun lives on. His invention didn't just build ships. It saved time, saved lives, and reshaped how we join steel. All because one ordinary welder dared to dream. After the war, Ted Nelson found himself standing on a quiet pier, overlooking the same waters where he'd once watched destroyers and submarines glide into service. The air was peaceful now. No hammering, no grinding steel, no thunder of industry. For the first time in years, Mare Island was calm. The end of the war had silenced the chaos, but it had also left many men like Ted wondering what came next. He reached into his coat pocket and pulled out a small brass stud, one of the first he had ever welded with his prototype gun. The edges were worn smooth from being handled so often. For Ted, it wasn't just a piece of metal. It was proof that an idea, even one born from frustration and long nights, could change the course of history. A voice called out from behind him, "Mr. Nelson, they're ready for you." Ted turned to see a young Navy officer jogging toward him, holding a clipboard. The officer was polite, a bit nervous. Ted smiled faintly. He'd been invited to Washington, D.C., to demonstrate his device before a board of naval engineers and industrial advisors. His invention had already spread through nearly every major shipyard, but now the Navy wanted it standardized across post-war manufacturing. "Guess we're not done yet," Ted said quietly, pocketing the stud and following the officer. Washington, D.C., 1946. Inside a government workshop, under the watchful eyes of uniformed men and civilian engineers, Ted set up his welding gun. The room smelled of oil and ozone, familiar scents that felt like home. A thick steel plate was clamped to a bench. Cameras were rolling. This was being recorded for documentation. Ted inserted a stud, pressed the gun against the surface, and pulled the trigger. A short, sharp hiss filled the air. When the light faded, the stud sat perfectly welded to the plate. The chief engineer leaned forward, inspecting the joint. Solid, seamless. He nodded, visibly impressed. "Gentlemen, this could revolutionize heavy construction." Ted stayed modest. "It's just faster," he said. "That's all I ever wanted, to make it faster and safer." But his words understated the truth. What Ted had done went far beyond saving time. His process eliminated dangerous scaffold work, reduced labor fatigue, and allowed thousands of unskilled workers, many of them women recruited during the war, to weld with precision. His tool turned ordinary hands into efficient, capable builders. The Navy soon granted him a full production license. Nelson Stud Welding Corporation was founded shortly after, and within a few years, his invention became the standard method of fastening across multiple industries: shipbuilding, bridge construction, automotive assembly, even skyscraper fabrication. By the early 1950s, the United States was in a new kind of race, not for survival this time, but for progress. Cities were climbing skyward. Bridges were spanning wider. Rivers, factories were pushing out cars, airplanes, and engines faster than ever before. And everywhere, from the skeleton of the Empire State Building to the frame of a B-52 bomber, Nelson's welded studs were quietly holding the world together. Ted's office, located in Cleveland, Ohio, was small but buzzing with energy. Engineers from all over the country visited to see his machines, new, sleeker versions of the original gun. They were electric, compact, reliable. Some could weld dozens of studs per minute. One afternoon, as he watched a young technician run tests on a new model, Ted felt a wave of nostalgia. The room smelled of burnt flux and ozone, the same scent that had once filled Mare Island. He thought of the men he'd worked beside, the long nights, the risk of failure. Many of them were gone now, scattered to different jobs or back to civilian life. A newspaper clipping hung on the wall behind him. Innovative welding gun credited with saving 50 million man-hours during war. Ted had read it once, then pinned it up and never looked at it again. He didn't need the reminder. Years passed. The stud welding process evolved. The guns became lighter, the control units more precise. But at the heart of it all remained the same simple principle Ted had discovered in that dim corner of the shipyard. A controlled arc, a timed plunge, and the unbreakable bond between two metals fused by human ingenuity. In 1957, Ted attended a conference of mechanical engineers in Chicago. He was now in his late 50s, his hair streaked with gray, his hands still rough from years of work. As he stood at the podium, facing hundreds of professionals, he began his talk with the same humility that had defined his life. "Gentlemen," he said, holding up a stud between his fingers, "this little piece of steel may not look like much, but during the war, it held together decks, hulls, and bridges faster than anyone thought possible. It saved time, it saved lives, and it reminded me that innovation doesn't always come from a laboratory. Sometimes it comes from a workshop at midnight." Applause filled the hall. But Ted, standing there under the bright lights, only smiled softly. He wasn't thinking about glory. He was thinking about the first time he'd pulled that trigger, the smell of molten steel, the spark that had changed everything. In his later years, Ted retired to a small house outside Cleveland. He spent his mornings tinkering in his garage. Old habits die hard, and his afternoons reading technical journals or watching ships glide across Lake Erie. One evening, his grandson, a boy of 12, wandered into the garage and found Ted working on a model ship. The old man's hands were steady as he glued tiny steel studs to the miniature deck. "What are those, Grandpa?" the boy asked. Ted looked up, smiling. Those are studs. Little pieces of steel that hold big things together." "Like screws?" "Better than screws," Ted said, his eyes twinkling. "They don't just hold things, they become part of them." The boy thought for a moment, then nodded. "Like people, right? When they work together?" Ted chuckled. "Exactly like people." In the decades that followed, Nelson Stud Welding grew into an international company. High-rise buildings, offshore oil platforms, and even spacecraft all used variations of Ted's original design. Engineers refined it, automated it, digitized it, but they never forgot the man who started it all. When Ted Nelson passed away in 1969, newspapers remembered him as the mad welder who revolutionized shipbuilding. His obituary was brief, just a few paragraphs, but to those who knew the story, it carried weight. At Mare Island, long after the shipyard had been decommissioned, a small brass plaque was placed near one of the old dry docks, asterisk in honor of Ted Nelson, whose simple idea welded together the ships that helped win a war. Asterisk, the wind off the bay still carried the faint tang of salt and steel. If you stood there at dusk, you could almost hear the echo of hammers and welding arcs. And maybe, if you listened close enough, the faint click of a trigger, followed by a flash of light that once saved 50 million hours and helped change the world. The spring of 1940 brought with it a strange tension that even ordinary factory towns could feel. Across the Atlantic, Europe was burning. France had fallen in weeks. Britain stood alone, and in every cafe and newsstand, people whispered that the United States would soon be drawn into the fire. Yet in the small industrial town of Peoria, Illinois, a wiry man with burn-scarred hands and a voice like gravel was waging his own war against bureaucracy, against disbelief, and against the limits of steel itself. His name was Harold Hal Anderson, and to his coworkers, he was simply the Mad Welder. Hal had grown up during the Depression, a restless kid who never fit in. He quit school at 15, learned welding in a railroad shop, and by 25 had a reputation as a genius with metal and a temper that could melt it. When war orders began to pour into the factories, Hal found himself at the Springfield Armory subcontractor plant. helping to produce prototype receivers for the M1 Garand. But what obsessed him wasn't the rifles they built. It was the the endless hours lost machining every component by hand, the rejected parts piled like scrap mountains behind the plant. One night, after a 12-hour shift, Hal stayed behind. The foreman's lights were out, and the shop was silent except for the hum of the power lines. He took a sheet of scrap steel, heated it until it glowed, and began to hammer and weld it into a crude, box-like frame. His idea was simple. A gun. That could be built like a car asterisk, not a Swiss watch. Something so easy to produce that even a teenager with minimal training could assemble it dot by dawn. He had a rough mock-up. It looked ugly like a plumbing pipe with a trigger, but it worked. He called it the pipe rifle. When he demonstrated it to his supervisor, the man laughed. "Anderson," he said, "no one's going to hand a soldier a sewer pipe and call it a rifle. The ordnance department would have my hide." But Hal wasn't joking. He'd studied the reports from Europe, the German blitzkrieg, the rapid overrunning of countries. He understood that quantity, not perfection, was what won wars. He filed for a provisional patent himself, using money he didn't have, and sent blueprints to the U.S. Army Ordnance Corps. The response came 3 weeks later. Design rejected. Structural integrity unsound. Lacks precision required for field use. That letter could have ended the story. But it didn't, single quotes T, that because 2 months later, a colonel named George M. Chin, an ordnance engineer with a background in both machine guns and field improvisation, came across Hal's blueprints while reviewing rejected designs. Chin was eccentric. A self-taught mechanic, an inventor who'd once fixed aircraft guns using parts from jukeboxes. He saw potential in Hal's crude concept. What if, he thought, this design could be adapted for mass production? Chin called Hal to Washington. The trip nearly broke him. Hal had never left Illinois before. He arrived at the War Department in a cheap suit, carrying his welded prototype wrapped in cloth. The officers in the room stared at it with polite disbelief. But when Hal loaded a dummy cartridge and fired it into a sandbag, the room fell silent. The mechanism worked rough, but functional. Chin ordered tests at Aberdeen Proving Ground. The pipe rifle, jammed often, overheated and failed after a few hundred rounds, but its simplicity stunned the evaluators. It could be assembled in under an hour with no special tools. "It's not a rifle," one engineer said. "It's a concept, a production concept." The military didn't adopt the gun, but they adopted its manufacturing principle. Hal's crude design became the seed for a new way of thinking. How to build weapons fast, cheap, and durable enough for total war. When the U.S. entered the war in December 1941, the industrial machine roared to life. Chin's team, inspired by Hal's approach, began re-engineering everything from aircraft mounts to submachine guns using weldable frames and stamped components. Hal was hired as a consultant not officially recognized, but present in every blueprint meeting. His once rejected idea spread like wildfire through the design bureaus. The biggest transformation came in 1942 with the .3 grease gun. Designed as a cheaper, faster-to-produce alternative to the Thompson submachine gun, it embodied Hal's philosophy: stamped steel parts welded together, simple blowback operation, and an assembly time that took a fraction of the Thompson's. Each M3 required 75% fewer man-hours to produce. Hal stood in the Detroit plant watching the first M3 roll off the line. Thousands would follow millions by war's end. Soldiers at first mocked it as a toy gun, but on the battlefields of France and the Pacific, it earned respect for its reliability. By 1944, U.S. ordnance production had saved an estimated 50 million man-hours thanks to the manufacturing principles pioneered by Hull's mad idea. It wasn't just the guns, it was tanks, jeeps, aircraft mounts, all benefiting from the shift to weldable stamped steel construction. But Hal himself never sought credit. He returned to Illinois after the war, living quietly in a small house, filled with tools and blueprints. In 1951, George Chin published The Machine Gun, Vol. 1, a massive technical history that, in a footnote, mentioned an unnamed civilian welder whose concept of simplification influenced wartime design. That was him. Decades later, when the Smithsonian curated a collection of wartime innovations, they found an odd welded prototype with HA stamped into the metal. No records existed, no patent survived, just a relic of one man's obsession. And the idea that sometimes the craziest designs change the world. Hal Anderson died in 1973, his name largely forgotten. But every time an M3 grease gun appears in a museum, or in the hands of a World War II reenactor, a fragment of his rebellion against waste and over-engineering lives on. His rejected gun never fought in battle, but its philosophy armed an entire generation. When the war machine hit full stride in 1943, the United States became what President Roosevelt called the arsenal of democracy. Every foundry, every mill, every assembly line pulsed with urgency. In this vast industrial orchestra, Hal Anderson's influence echoed quietly, shaping the rhythm of production without anyone realizing whose tune they followed. Factories that once crafted luxury cars or farm equipment were now retooled for destruction. Ford's River Rouge plant, once a marvel of peacetime engineering, was producing one B-24 bomber every hour by late 1944. But behind that staggering speed were ideas that had once been laughed at. Welding over riveting, stamping over machining, function over form. Hal's concept of simplification had metastasized through every blueprint in the defense network. At first, the old engineers resisted. A welded frame? They'd scoff. That'll crack under stress. Stamped steel? That's for toys, not weapons. Yet again and again, the data humiliated them. Welded frames held firm. Stamped components survived the battlefield. The M3 grease gun, born from Hal's pipe dream, was proving its worth in North Africa and Italy. Reports from the front described soldiers using it in mud, sand, even underwater, without failure. George Chin, now working directly with the Navy's Bureau of Ordnance, continued to champion Hal's ideas. He wrote memos that circulated across the War Department, arguing that simplicity is a form of strength. Those memos reached Detroit, where Charles Sorensen, Ford's production chief, studied them closely. Sorensen had been struggling to meet the Air Force's demand for bombers, where every rivet meant another delay. The M3's success gave him the proof he needed. In early 1943, Ford invited Chin and through him Hal to consult on the *B-24 Liberator Assembly redesign. Hal arrived at the massive Willow Run plant, a place so large it had its own weather patterns. He stood on a catwalk overlooking the miles of conveyor belts, sparks flying from welders below like orange fireflies. "You built all this to fly," he muttered to Sorensen, "but you still build it like it's a carriage." That meeting changed everything. Under Hal's guidance, Ford began applying welded joints in non-critical areas of the airframe, replacing thousands of rivets. The change shaved off hundreds of hours per bomber. When combined across production lines, it meant tens of thousands of man-hours saved each month. The Army Air Forces approved, and within 6 months, the design change spread to other manufacturers. Hal's life, once small and quiet, had turned into a blur of train rides. blueprints, and factory floors. He'd never gone to college, never. Studied engineering formally, yet he was lecturing metallurgists twice his rank on efficiency. He slept in workshops, ate in cafeterias, and spent nights staring at glowing furnaces as if they whispered secrets to him. His co-workers still called him mad, but now it was with admiration. One of his most remarkable moments came in 1943 at the General Motors Saginaw plant, where he was asked to inspect a new design for the M1919A6 machine gun. The existing version was durable, but painfully slow to produce. Hal examined the blueprints and simply said, "You're machining art when all you need is a hammer." Within weeks, his suggestion to stamp and weld certain receiver components cut production time by 40%. He refused awards, refused promotions. "I'm not a soldier," he said to one colonel, who offered him a medal. "I'm just trying to stop wasting time." Yet by that year's end, the U.S. War Production Board estimated that changes directly inspired by Hal's manufacturing philosophy had saved the equivalent of 50 million man-hours time that had been redirected into tanks, planes, and ships. Meanwhile, overseas, the weapons born of his ideas were shaping the battlefield. In Normandy, paratroopers carried M3 grease guns during the D-Day invasion. Tank crews used them as compact defense weapons in close quarters. Even resistance fighters in France received airdropped crates filled with the inexpensive mass-produced submachine gun. For every one Thompson, 6 M3s could be made, and the war demanded numbers. Hal received occasional letters from soldiers who had no idea who he was. "Your gun saved my life," one read. "It jammed full of mud, but she still fired." He kept those letters in a cigar box beside his workbench. To him, they were worth more than any medal, but the pace of war was merciless. In late 1944, during a visit to the Bethlehem Steel Shipyard, Hal collapsed from exhaustion. Doctors told him he had severe welding fume poisoning and lung damage. They ordered him to rest. He laughed. "People are dying by the minute overseas." He told Chin, "You think I'm going to sit on my ass?" Still, his body was breaking down. Years of inhaling smoke and metal dust had scarred his lungs beyond repair. He moved slower, coughed constantly, but refused to quit. "If I stop," he told a friend, "everything stops." As 1945 dawned, the war began to tilt toward victory. American industry had outproduced every Axis nation combined. When Germany finally fell that May, Hal watched the news on a black-and-white radio in a Detroit boarding house. He didn't celebrate. He just stared at his hands, burned, scarred, trembling, and whispered, "We made it." After the surrender of Japan in August, the factories fell silent. Thousands of workers went home. The noise, the urgency, the fire, it all vanished. Hal felt lost. For 5 years he had lived in a storm of sparks and steel, and now silence. He returned to Illinois with little more than a duffel bag and a stack of blueprints. He tried to find work in peacetime industry, but no one wanted a welder who talked like a philosopher. When he spoke about simplifying production, people smiled politely and said, that was wartime thinking. The nation moved on. Hal began building small inventions in his garage tools, farm machines, experimental welders, but none caught attention. To neighbors, he became the strange old man who worked through the night, his garage glowing orange like a forge from another era. But for him, it wasn't madness. It was purpose. He stayed in contact with George Chin, who by the 1950s had become a recognized authority on automatic weapons. Chin often wrote to him, "They'll never know what you gave them, Hal, but history remembers in its own way." Sometimes, on quiet nights, Hal would open that cigar box, read the old letters from soldiers, and smile. In those moments, the ghosts of the war didn't haunt him. They saluted him. The world that emerged after 1945 was one Hal Anderson hardly recognized. The factories that once thundered with the sound of war now built refrigerators, cars, and washing machines. The same assembly lines that had birthed bombers now churned out peacetime dreams. And yet, hidden beneath the glossy chrome and pastel colors of America's new consumer age was the quiet heartbeat of Hal's legacy efficiency, born from necessity. Automotive engineers had adopted welded frames wholesale. Aircraft production had forever shifted to modular assembly. Even small appliance makers now used stamped components to speed up fabrication. Few people realized that the man who had inspired this revolution lived alone in a rusting house on the outskirts of Peoria, welding scraps into art no one would see. By 1950, Hal was in his late 40s but looked 20 years older. His lungs were weak and his hands trembled from nerve damage. But he still worked. He couldn't stop. The world might have moved on, but his mind was trapped in blueprints. He often muttered to himself, sketching in grease pencil on his workshop wall diagrams of impossible machines. A car you could build like a gun, a bridge that builds itself. Then, one winter afternoon in 1951, a thick envelope arrived. The return address read, Department of the Navy, Bureau of Ordnance. Attention, Major George M. Chin. Inside was a typed letter and a galley proof of Chin's massive book, Machine Gun, Volume 1. The note was simple, greater than Hal. I've done my best to tell the story right. The world won't know your name, but it will know your idea. You made us faster, and that speed saved lives. G. Hal read the note 3 times. In the galley, there was a small footnote buried on page 312. A civilian welder's experimental. Simplified firearm design, though never adopted, profoundly influenced wartime production philosophy. He laughed quietly. A footnote, he said. That's all I ever was. But there was no bitterness in his voice, just pride. By the 1950s, America was no longer building to survive. It was building to dominate. The Cold War had begun, and a new kind of arms race demanded innovation at an industrial scale. When? The U.S. began developing jet aircraft, missile systems, and atomic-age machinery. They built them using the same principles Hal had pioneered: simplification, standardization, and welded modular construction that the new generation of engineers didn't know his name, but they lived in his world. They studied lean manufacturing, process optimization, and time efficiency, never realizing those were academic echoes of one mad welder's obsession. In 1956, Hal was invited quietly to consult for a short-term project at the Rock Island Arsenal, where they were testing automated assembly systems for small arms. The engineers there were young, college-trained, confident. When Hal entered the room, with his worn jacket and oil-stained hands, they mistook him for a janitor. Only when George Chin introduced him as Asterisk, the man whose ideas made your careers possible, did they stand at attention. Hal walked among the machines, watching robotic arms weld parts with precision that once took men days to complete. You made the world faster, Chin told him. What do you think? Hal smiled weakly. I think speed's only good if you remember why you needed it. That night, as they shared coffee in the canteen, Hal confessed that he feared what came. Next, we've made production so easy, he said, that someday we might forget the weight of what we build. Chin nodded. Maybe, but men like you remind us what purpose looks like. By the early 1960s, Hal's health was in sharp decline. He had outlived the war, outlived the factories, even outlived the fame that should have been his. One of his last projects was building a miniature version of his pipe rifle, this time perfectly welded and polished. He called it the reminder. He never fired it. It wasn't meant to shoot. It was a symbol of the lesson he had spent a lifetime teaching, that asterisk innovation isn't about beauty, but necessity asterisk dot. He donated the model to a local technical college, along with a handwritten note. Don't let anyone tell you a bad idea can't change the world. The world just needs time to understand it. No one knew who he was. The students displayed it in a dusty cabinet labeled Experimental Firearm, 1940s Unknown Maker. In 1973, Harold Anderson died quietly in his sleep. His workshop lights had been off for 2 nights before a neighbor checked on him. On his desk lay an unfinished blueprint for a universal welding armature, something decades ahead of its time. He had died dreaming of better tools. When George Chin heard the news, he arranged for Howell's prototype pipe gun to be preserved at the Smithsonian's National Museum of American History. The curators didn't know its story, but Chin did. In his diary that year, he wrote, "History rarely honors its builders, but every time a soldier fired an M3 or a bomber rolled off a line built on welded steel, a mad welder's hand was there, invisible, guiding it." In the decades that followed, historians traced the lineage of wartime manufacturing and discovered the strange figure who had sparked it all. Hal became a whispered legend among collectors and engineers, a mythic craftsman who changed the world with a rejected idea. Today, in the Smithsonian archives, a small rusted prototype sits under glass. The tag reads asterisk, Experimental Simplified Firearm, circa 1940, maker unknown. Asterisk, but if you look closely, scratched faintly beneath the steel, you can still see 2 letters, H. Decades passed. The world Hal Anderson had helped shape moved faster than anyone could track. Jet aircraft streaked across skies. Nuclear submarines prowled silently beneath oceans, and automated factories churned out goods with speed unimaginable. In the 1940s, yet in all this, very few knew the name of the man whose vision had quietly laid the foundation for such efficiency. In the early 2000s, a young engineer named asterisk Maya Thompson, researching the history of wartime production methods, stumbled upon a small reference buried in George Chin's archives at the Library of Congress. A footnote mentioned a civilian welder whose simplified firearm design influenced mass production techniques. Intrigued, she dug deeper. In dusty boxes at the Smithsonian, she found a small, rusted prototype labeled Experimental Simplified Firearm, circa 1940, maker unknown. And there, faintly etched into the metal, were the letters asterisk asterisk H.A. asterisk. Maya felt a chill run down her spine. She realized she had found the work of Hal Anderson, the man known only in whispers among wartime engineers. Over the following months, she pieced together his story through letters, patents, and oral histories of surviving workers from Mare Island and Ford. She discovered something remarkable. Hal's original welding gun design, crude as it was, had directly influenced asterisk, not just submachine guns, but every fastened assembly that prioritized speed over craftsmanship during World War II. Asterisk from B-24 bombers to M3, grease guns to the decks of naval destroyers. Nearly every major production line carried the fingerprint of his mad idea. Maya's research caught the attention of the Smithsonian, which launched a full restoration project. They cleaned Hall's original welding gun, carefully documented the mechanism, and even held a small exhibition showcasing how a single man's ingenuity could ripple across an entire war effort. Engineers marveled at its simplicity. The device, in its raw form, was elegant in its own chaotic way. No computers, no modern automation, just a man, a spark, and a belief that things could be done better. The exhibition, titled "The Mad Welder Who Changed the War," drew historians, engineers, and veterans. Old-timers who had once laughed at Hal's ideas now stood in quiet awe, realizing the truth. One rejected invention had saved an estimated 50 million man-hours. Meanwhile, modern weapons manufacturers and industrial engineers began studying Hal's original principles. Surprisingly, his philosophy simplify, weld, assemble fast found new life in asterisk 3D printing, modular robotics, and automated assembly lines. Asterisk tools and machines were designed to work with minimal human intervention, echoing Hal's insistence on efficiency and reliability. In classrooms, students learned about lean manufacturing, often unaware that the principles stemmed from a single man's midnight experiments in a small Illinois garage. Professors cited Hal's story as a case study. Innovation doesn't require degrees or fame. It requires persistence, audacity, and a refusal to accept inefficiency as inevitable. And then there were the letters. The letters from soldiers saved by M3 grease guns, from men who had never met him, from engineers who unknowingly applied his ideas. They were rediscovered and compiled in a small volume titled Asterisk, Letters to the Unknown Welder. Asterisk, the world saw the human impact of Hal's labor, lives saved, battles won, and war machines built faster than anyone thought possible. Perhaps the most poignant recognition came when a naval historian compared deck construction on World War II destroyers to modern assembly methods. The conclusion was clear. The innovation of one mad welder had redefined production efficiency in ways that shaped both military and civilian engineering for generations. And so Hal Anderson, once ignored, once dismissed as eccentric, became immortal, not through medals, monuments, or public acclaim, but through asterisk, the lives he touched, the time he saved, and the ideas that lived long after him. Asterisk, on a quiet evening at Mare Island, where once sparks flew and hammers rang, wind still whispers across the empty dry docks. If you stand there and look closely, you can almost imagine the figure of a man in a welding mask, arc glowing, a prototype in hand, shaping the world one joint at a time. A mad welder whose rejected gun became a lifeline for an entire nation. And somewhere, deep in the archives, a rusted welding gun rests under glass. The label reads, asterisk, experimental simplified firearm, circa 1940, maker unknown. But for those who know the story, it will forever carry the name Harold Anderson, asterisk. Long after the last ship had left Mare Island, long after the factories had been converted back to civilian production, the story of Harold Anderson lived quietly in the corners of history. Few knew his name, fewer still his face, but every welded joint, every stamped component, and every piece of machinery that moved faster because of his ingenuity carried his invisible signature. In a small, dimly lit workshop in Peoria, a grandson of one of Hall's friends discovered a box labeled, simply, do not discard. Inside lay sketches, prototypes, and letters, an entire archive of a man who had given everything to a nation he loved, but had never sought fame or fortune. The letters from soldiers, written decades earlier, were brittle with age. Your invention saved my life at Normandy, wrote one. I carried your gun through the jungles of the Pacific, and it never failed. For the first time, the family understood the magnitude of his work. 50 million man-hours saved hours that had allowed soldiers to survive, engineers to produce, and the nation to endure. Historians eventually pieced together the full story. Museums mounted exhibitions, engineers studied the blueprints, and students learned about the quiet heroism of someone whose genius was practical, relentless, and unseen. The welding gun, once rejected and dismissed as mad, became a symbol, asterisk, that perseverance, creativity, and courage can change the course of history without recognition. Asterisk in classrooms, in workshops, and in factories, Howell's principle endured. Simplify, adapt, and focus on impact over appearance. It was a lesson not only in engineering, but in life. Sometimes, the mad idea, the one everyone else rejects, is the one the world desperately needs. And then there was the quiet legacy of the men who had built alongside him, or who had benefited from his ideas without knowing it. Their lives were a testament to the unseen labor of one individual. Ships launched faster. Bombers left assembly lines sooner. Tanks rolled into Europe earlier. Soldiers lived because someone refused to accept inefficiency. That was the true scale of Hal Anderson's achievement. In the evening light, the Smithsonian's glass case reflected the rusted welding gun, the brass studs, the faded blueprints. Visitors walked past, some stopping to read the label. Experimental simplified firearm, circa 1940, maker unknown. Most moved on without knowing, yet in that reflection lay the invisible impact of one man who had refused to be ignored. So Harold "Mad" Anderson remained, a quiet figure in the history of war, a whisper in the hum of industry, a man who proved that genius doesn't always announce itself with accolades. Sometimes it speaks in the faint glow of molten steel, the rhythm of a hammer striking metal, and in the millions of hours it saves across a nation. The world had changed, and in every corner, in every assembly line, and in every soldier's handheld weapon, Hal's vision lived on. Not in fame, not in fortune, but in the very heartbeat of progress. And somewhere, if you listen closely, the faint hiss of a welding arc still echoes through time, a reminder that one mad idea, one rejected gun, had saved not just hours, but lives, and had quietly helped to shape history itself.